Okay, on example 5, we have a ship that is, there are two ships that are 150 kilometers apart at noon. All right. One of them is going to be sailing towards the other one as the second ship is going to sail north. All right. Let me draw that situation for you. And there's a couple different ways you can go about this one, but I feel like calling the variables x, y, and z is going to work out pretty good. All right. So this is 150 kilometers to begin with. All right, but that's not the distance that we're going to be dealing with. All right, I'll show you that in just a second. All right, and then we're concerned with at what rate that distance between the two ships is changing. All right, so it says A is 150. So yeah, so B is here, A is here, but moving in this direction. Okay, and then B is moving in this direction, and we're told how fast those are going. So let's call this actual distance here. It's not going to be 150 at first, but we're going to call it. I mean, it is 150 at first, but it's going to be shortening. We'll call that x, and then we'll call this y. All right. So we do know this then. So we know that x squared plus y squared is equal to z squared by Pythagorean theorem, of course. All right. And then we are given that they're 150 apart, but then as far as the rates go, A, we know is, sorry. A is going to be dx dt. Now, here's the thing though, that distance is shortening, all right, because they're moving this direction. So this rate then is negative 35, okay? And then dy dt, though, that length is getting longer, okay? So since that's happening, this one's going to be a positive. So that's 25. And of course, they're kilometers per hour. Okay, so then it says, all right, find dz dt, all right, when the ships have been sailing for 4 hours, right? Because we're asked for that at that moment. Okay, well, so dz dt, and t is still not our variable though, but so I don't know. We're just going to kind of leave that blank for a second because we don't know what to put there as far as the variables go. All right, so let's go find those out then. All right, but we can go ahead and do the derivative first on this with respect to time. So I've got 2x dx dt. Oh, that's doing really good. And 2y dy dt. And the last one is 2z. This is very much like an AP kind of question here. This one's awesome. And dz dt is what we're trying to find out at a particular moment. But as you can see, t's not the time is not our variable throughout this entire thing. So let's find out what is then. Okay, so it is 4 hours, and so we do know that dx dt, this length here is shortening by 35 kilometers per hour for 4 hours. All right. So that means then that x would equal, at this very moment we're talking about, the 150, and then we're getting rid of 4 of those 435s. Okay, and if I'm not wrong, that's 10. All right, so over here then I can change this and not to that to say, all right, find dx dt when x is 10. Okay, and then y is started at nothing, and so y is doing that, and it's going 25 kilometers per hour for 4 hours. Well, that's going to be 25 times 4. Yeah, this one's pretty challenging, but I think now that we've got this all labeled, we should be good to go because we can substitute everything in. So that's 100. All right, and let's just go. All right, so then I can say that also, by the way. So, and y is also 100. All right, we didn't know that at first. Had to do a little bit of work. I mean, we could have figured it out and then gone to this fine part, but but I just kind of did it afterwards. Okay, so let's just substitute in everything we know. All right, so that's part 2. All right, so part 2 is substitute in everything that we now know. We know that x is 10, so this is going to be 20. And we know that dx dt is shortening, so that's negative 35. We'll deal with the units later. All right, so we got that. And then y was 100, and so we've got 200 of that. And dy dt was 25, right? Yeah, 25. Okay. And then this equals 2 times z at that very moment. So we'd have to do Pythagorean theorem to find out z. I haven't done that yet. All right, so Pythagorean theorem to find z. So let's go off here to the side here. So we're going to have to go 10 squared plus 100 squared equals z squared. Pretend like that's a good z. Z squared. All right, what was that? 100, and that's 10,000. So we've got 10,000, 100, and the square root of that. And I'm just going to leave it. I'm just going to leave it like that. All right, so that's equal to z. Okay, cool. Okay, so all right, so I've got 2 of those. So I've got 2 of the 10,000 100s, and I'm looking for dz dt. This one is really cool. Really cool. All right. Okay. All right. So I'm just going to break out a calculator here. I don't feel like thinking about all this. So what we've got, 20 times negative 35. All right. Plus 225s. That's my left-hand side. All right. And then I'm going to divide that by 2 and also the square root of 10,100, which I'm really tempted just to leave it like it is. All right, so this is 4,300. So divide that by 2, and you got 21. So my numerator is going to be 2150, and I'm sure this square root simplifies, but I just don't want it. I just don't want to do it. So it's going to be a square root of 10,100. And you know it simplifies a bit because it's got hundreds in there for sure. All right. Is that going to bother you? All right. It is me. So, all right. So let's do this. So we know we're going to have definitely 100 as a factor of that denominator. And so we know there's going to be a 10 here. And so that would give me a 215 on top once I do that. And now I just need to find out how many times 100 went into 10,100. All right. So again, it's 101 of them, right? Yeah, it's 101. Yeah, duh. Okay, so 101. Sorry, 101, and there we go. All right, so that's simplified. You didn't have to. If it's a free response, you don't have to simplify. But here we are. I'm doing this on the fly, so just doing the best we can. So 215 over the square root of 101, and I say leave it just like that. That is the rate in which that's changing. Of course, now this is going to be in kilometers per hour, so we do need to say that. So kilometers per hour. That's what that dz dt is equal to. All right, act like that's a big fraction mark. Okay. Woo-wee. All right. That was a doozy. That's a good one right there.